Alright, so the last problems for this week, and really for the course, are hyperbolas. So, again, as with the parabolas and the ellipses that we were dealing with, in order to graph these, your equation has to be equal to 1 on this side. So if it's not, you're going to divide every term in your equation by whatever this value is over here. And then we're going to simplify a little bit. So this is, of course, y squared over 25 minus x squared over 4. And then, of course, that now equals 1. So these problems are initially start much like the ellipse problems that we did, in that you're going to identify A and B. The trick is with these, however, is when we're going to graph these, what's going to matter is which term comes first, the y or the x, because that determines whether our hyperbola looks like this or if it looks more like this. So if the y term comes first, then it's going to look like that graph. If the x term comes first, it's going to look like this one. So, since the y term comes first, we know that our graph is going to have roughly this kind of shape. So again, we're going to identify our a and our b terms. So in the case of hyperbolas, a and b are always associated. This is always going to be the a. That's always going to be the b. It's going to go in order, in other words. It's just the x's and the y's that may be in a different order. But a and b will always be, a will always be associated with the first term, b will always be associated with the second term. So for this problem, again, a squared is 25, therefore a is plus or minus 5, b squared is equal to 4, therefore b is plus or minus 2. Okay, so now we have the basics to sort of start graphing. The only other thing that we need to identify, however, are the asymptotes. Sorry, brain fart there for a moment. We need to identify what the equations for the asymptotes are. So, if you look at the brown box on page 607, you can see in the fine print the equations for these. So, again, since our equation for our hyperbola starts with a y term, our equations for our asymptotes are going to be y equals plus or minus a over b times x. Okay, so we're just going to plug in our values for a and b here. So, and you can kind of ignore the plus and minuses down in here, because regardless of which ones you use, you're going to end up with two possible outcomes for a divided by b. It's either going to be positive or it's going to be negative. So, y is going to be equal to 5 over 2x. So that's one asymptote. The other one is y is negative 5 over 2x. And so what I meant earlier is if you chose the positive 5 and the negative 2, then you would have had this outcome. If you'd made them both negative, you would have had this outcome. So regardless of what values for a and b that you pick, you're going to end up with one of these two lines. Okay, so now we're ready to graph. And for those of you who choose to attempt these particular homework problems, there's a lot involved. So if you choose to do them, I will give you some extra credit. So let's go over to the graph. Okay, so I've put in my asymptotes already, and again, as a reminder, you actually only need the a value to graph your hyperbolas. Because again, once we've identified which way the graph opens up, which in this case, we already talked about the shape of the graph is going to be like this along the y-axis, since the y value came first. You need to just identify where your vertex is, and then you can sketch it from there. You can actually pick some specific points if you like, but that's unnecessary for me. So you should be able to plug in those previous line equations, the y equals 5 halves x and negative 5 halves x, in order to graph them if you're going to do that in Microsoft Word. Or you could just sketch them in like I've done here if you're doing it by hand. So this value here, we're adding and subtracting from the center of the graph, which again, for this one, it's at 0, 0. We'll look at one where the center has been shifted. So my vertices for this graph are at 5, and then also at -5. On my parabola, for each one, opens up, and then opens down. Okay, so there's the basics for graphing it. So again, the problem asks for several things. It asks for domain and range, which for these problems can be a little tricky. So for domain, again, we're looking at all possible x values. And it's kind of hard to judge from the graph, but again, if you imagine these extending off into infinity, there is no gap in the possible x values you could have. If you look down here, there's a point here for x, there's a point here for x, there's a point, there would be a point here. So the domain is -infinity to infinity for this problem. It would be different if this hyperbola was shifted the other way. Then we would have an infinite range, but we would have limits on the domain. But for this problem, our domain is infinite, but the range has limits because there's this hole in the graph right here where there are no y values for any given x value. So we're going to look at this, and this is where it gets a little confusing, is because we've actually got two pieces for range. So y can be anything bigger than 5, right? Because we've got values for y along here, but we don't have anything in this whole chunk here. And then y can also be less than -5. So we have a union range here, meaning we've got two different possible values, possible ranges for the y values. So the first one, we have one at, so y can get infinitely small, but can't be any larger than -5, and then that u means the union, and then there's a break until we get to 5 on the y-axis, and then that goes off into infinity. And this is why I'm giving people extra credit for attempting these, because they are sort of weird, tricky problems. Alright, so we've already, the center was relatively straightforward because we didn't have any h and k, so the center was 0, 0. And then our vertices, those are these right here. So we had a vertice at 0, 5, and then another one at 0, -5. Again, those are the vertices. And then the last thing, of course, it asks for is the foci, which for parabolas, I'm sorry, hyperbolas, this one, our equation is now c squared equals a squared plus b squared. So foci is going to be at c squared equals 25 plus 4. So c squared is 29, therefore c is equal to plus or minus the square root of 29. And again, that's good enough for me. You could actually graph these if you wanted to do that, however. All right, please let me know if you have questions.